Good afternoon, all. I'm sure you are ready for the today's class and eagerly waiting for the next topic to be covered. I think you should not have any problem in implementing the stat which we discussed yesterday. The last problem which I said was whether a given string is a palindrome or not. So I gave you a hint at the last. I just repeat that once again, those who have tried and if they want any help. So I say one way of doing this could have been, let's say I have, say, some string like this. So one way, method one, you could think of doing was that you keep on pushing R in this order you go. So you have a stack, you push R and then you push A, then you push A, D, do you push again D, you push whole string. Everything is pushed and later then once you have everything pushed, then you can easily think of now once they are pushed, you could say, okay, I will pop, compare with first element, then pop, compare with the next element, then pop, compare with the next. So proceed like this, pop and traverse the array, traverse your string also, and keep on matching and compare. As soon as there is a mismatch, you could easily conclude. That could be one way. But I tell you a better way. That why to do all this for full string? I say the same process you can easily do by just pushing up to half. This much portion you will push. That will mean effectively going R, A, D. Now, as the remaining string is going to be effectively repeated after this, then I can easily say I can pop and compare, then again pop and compare, pop and compare. So effectively out of the full string up to half, you push and now you pop and continue traversing. That can straight away do the things easier for you for even length of palindrome. And similarly, you can also plan a logic for the odd length also. So this much should be sufficient, and I am sure now you can easily try. Going further, let's talk of some more applications of the stack. So one application, you are already aware that for solving recursion or recursive executions, recursive function calls, all those internally get handled and processed via recursive stack itself. That was obviously understood. Not only that, have you ever thought that how you get your expressions computation? For example, if you write an expression like 5 plus 7 minus 6 multiplied by, let's say, 2 plus 3. Say you write like this. Now, how this will be computed? Some of you could be easily able to guess that first of all, you will be evaluating the parenthesis related component. Yes, very right. Because of the BODMAS rule, you will always follow the rule and bracket-based calculations done first. There could be multiple brackets, there could be multiple operators. After this, so you will first go try to look for brackets. If you found bracket, fine, you will say, okay, evaluate this. Within this, again, there could be some more brackets. Again, you have to proceed like this. Once done, now you will say, no, I cannot evaluate plus now. I cannot evaluate minus because star is to be evaluated first. Multiply is before add and subtract. So then maybe you will say evaluate star. After that, you will say, now I can evaluate these. Similarly, there could be many more complex operations and you have to do everything. So it requires many times you have to go through the expression. Multiple passes could be needed or multiple scanning of your this expression will be needed. And in general, we say multiple passes or multiple traversal of these for the total process to be completed. becomes probably one of the way, but not a good way of doing. So internally, computers don't work like this. Internally, my PC or computer calculates in a different manner. Internally, computers work on a different expressions. Such an expression is called infix expression. This expression is an infix expression, where word infix means the operator is in between the operands. So whenever you list the operator as in between operands, then it is called as an infix expression. For example, you write 5 plus 7. For the plus to operate, one operator is 5 and maybe 7 is another operator. You want to say 6 star 2. So star requires one operator on the left side, one operand on the left side, other operand on the right side. This is what we call as infix expression. On the other hand, there is another expression which is called as a postfix expression, which suggests that operator is written after its operands, but it has its own advantages. After its operands, and calculations or evaluation of postfix becomes much more easier. So that is what we are going to see now. And postfix expression, for example, for the above one will become 5, 7 plus 6, 2, 3 plus star minus. How do we get this? Don't bother. But this is the equivalent postfix expression for the above infix expression. But it has its own advantage. One advantage is no brackets are there. All brackets and BODMAS related rules all get automatically solved in this. Of course, based on that only, this expression has been computed. And once this is ready, I say this is directly evaluatable. That is the advantage of using postfix expression. Here, plus means it is having its previous two operands just before that always. This plus will mean its previous two operands are just before this and like that. So advantage will be in a single go, you will be able to calculate the value for this expression. Let's continue discussing this further and understand it in more detail. I say, if your expression was 5 plus 7, let's say we had earlier 5 plus 7 plus 6, 5 plus 7 minus 6 star 2 plus 3. If this was infix expression, equivalent postfix is 5, 7, 6, 2, 3 plus star minus. But if my expression was, let's say, 5 plus 7 minus 6 star 2 plus 3, of course, its equivalent postfix will be different, which will be 5, 7, 6, 2 minus 6, 2 multiply minus 3 plus. How it will come, we will see later. But that guarantees that whatever ordering of operators you wanted to ensure in the infix, same has been reflected properly into the postfix. But once we say that, my evaluation process is simple. I will say, I will go one by one. So if I have a 5, 7, 6, 2, 3 plus star minus, I will say start with this. This is 5, 7, and then I had 5, 7 plus, and like this. This was missing 5, 7 plus here. So 5, 7 plus. So I'll say, first of all, it's an operator, operand. Of course, it is needing some operator. Second operand, fine. Plus, as soon as plus comes, it means previous two are its operands guaranteedly. So as soon as I reach to plus, I will say this is overall computable and 12 becomes the value. 12 will become 5 plus 7. 5 is first operand, 7 is second operand. 5 is operand on the left side always, 7 is operand on the right side. I am assuming binary operator plus. Then comes 6 operand, operand, operand plus. Plus automatically means the previous two are its operands. So plus coming here will mean this will become 2 plus 3. So this overall will be calculated. This becomes here 5. 6 was already here. 5 is this because of this plus done. Then comes a star. Star will mean previous two again are its operands. This is operand 1, operand 2, 6 into 5. So this overall will be calculated and this will become 30. So then comes a minus. Minus again means the previous two are its operands. So one is 12, other is 30. It will calculate 12 minus 30 minus 18 being the result. And you could verify from this also, it will work 5 plus 7 minus 6 into 5. 6 into 5 is 5. 6 into 2 plus 3 is 5. So 6 into 5 will become 30. 5 plus 7, 12 minus 30 minus 18. On the other hand, if the expression was 5, 7 plus 6, 2 star minus 3 plus, I'm talking of this expression. So this will be calculated as 12. Then comes a star. Star will mean 6 into 2, 12. Then comes a minus. So minus will mean 12 minus 12, that will become 0. So 0 coming here. And after that coming a 3 plus. So 0 plus 3, that will mean it will become equal to 3. This you can verify here. 5 plus 7, BODMAS rule says this to be calculated. This becomes 12. 5 plus 7, 12 minus 12, 0 plus 3. So if my correct valid postfix expression is available, I will be able to convert that and calculate easily into the equivalent value. So that's the advantage of a postfix expression. So postfix expression is easy and straightforward to compute. Hence, my programming internally is always, although we write in infix expression, but internally computer calculates it over postfix expression. So in your programs, in any of your programs, whatever expression you write always infix expression. Then your compiler or operating system or your computer will ensure that this gets converted, the corresponding infix expression, to equivalent postfix expression. And how this is done? This is also done using stack. So stack has another application which we will see, that infix to postfix conversion is also done by using stack. Then expression evaluation or value computation, that is also done using stack, and your compiler or operating system will be able to do this evaluation over a postfix expression and give you result like minus 18, etc. So stack has its own both applications, the evaluation of postfix expression as well as conversion of infix to postfix. So let's go one by one now. So I want to implement postfix expression evaluation. And we will understand what is the role of the stack. Postfix expressions evaluation. What is the role of the stack? How stack will come into picture? So let's understand. So I say if my expression is 5, 7 plus 6, 2, 3 plus star minus. This was my expression. So how I use my stack is now we will explain. I say as soon as you start one by one, If it is an operand, it's not an operator, I will push into the stack. Why? We will be just understanding the reason for that. Then comes a 7, I will push into the stack. Plus needs just previous two values as its operands. So previous two means just previous last two, and a stack is the best opportunity to get last. So plus will mean pop out this, pop out this. This is your operand 1. This is your operand 2. Both will be popped out. This stack will be empty, and I will do 5 plus 7, that is 12. 12 was calculated. I will again send 12 into the stack because this is also going to be operand for someone. Then comes 6, push into the stack. Comes 2, push into the stack. Comes 3, push into the stack. Comes plus. Plus means pop out 2, topmost 2, and topmost 2 popped out, 2 plus 3 calculated, and 5 pushed here. Then comes star. Pop out topmost 2. 6 being operand 1 multiplied with the second operand, this is operand 2. So both have been popped out. 6 into 5, 30 calculated and pushed into the stack. Comes minus. Both operands will be popped out. 12 minus 30. Remember, the ordering is important. 12 is the first operand. Minus is to be applied because minus is a non-commutative operator. So 12 minus 30 will be calculated. Minus 18 will come and minus 18 will be pushed into the stack. Now function is over, or this expression is over. So my stack has the result available. That is minus 18. So this is how my stack becomes useful to solve problems like this. So let's go towards the programming aspect of this. And now we will do the final coding for this. So from programming viewpoint, I say we make certain assumptions. For the simplicity, we are assuming that the operands are single digit only. Why I am saying? Because otherwise you have to write a logic. For example, if I say 3, 5, 6 plus. Now, does this mean 35 plus 6? Does it mean 3 and 56? Or even 356 could be a single value, 356 also, and then it could be something other data needed. So then we will need a space also to be given. Space needed means I have to do, for example, if I write 3, 5, 6, 7, 2, 8, 4 plus. Now, does it mean each of these was a separate digit, or each of these was a separate operand, or we had 35 as separate operand, 67,284 separate, etc., etc. So for simplicity, we are assuming every single digit as a single operand. Of course, later you can improve your code to handle situations like this also. So number 1, operands are single digit. Number 2, assumption. The postfix expression is always valid, meaning that no imbalance of operands or operators come. Like if I write 5 plus, it's an invalid postfix expression because it has only a single operand available and plus came. So I am assuming nothing like this. Or 7, 6 is again an invalid because I'm saying 7 is one operand, 6 is another, but no operator available. So I'm assuming all those cases not coming. Of course, you should try to do and handle those also along with the programming. Then third assumption, operators which I'm going to use, I define precisely. Operators are, let's assume, binary operators being discussed, because in that case, exactly 2 operands needed always. So operators are binary always, and the operators being used are plus, minus, star, slash, and power symbol, cap. So I say 5 operators being used, and my postfix expression will always have single digit operands, operators out of these 5 only, and expression being always valid. And now I'm supposed to write the programming. So that makes the program to be simple. Later, once you are able to complete simple program, then you should try to change these assumptions and work for those situations also. How to do? Now let's understand what I have to write. I have to write a modular programming. So I will say evaluate postfix will be a function which I want to develop. Then what should be the parameter? What should be the return type? Fine. What should be the parameter? I need the postfix expression. Of course, I need that postfix expression to be supplied. And obviously, it will be an array. Array of what data type? You could think this to be of int data type because I'm talking of values 5, 7, etc. So you could say that this be an array. But I say this will be incorrect because you have no choice but to give it as 5, 7 plus 6, 2, 3 minus and so and so. It has to have some operators also. And you are not supposed to trouble the user to give data in a different manner. User will have the postfix expression like this only. Or it might be coming from some infix expression and there you have to operate. So you can't say, no, I will not accept that. So everything you have to handle as a programmer, but my expression is guaranteedly going to be then a char array type. There is no choice because you have to have characters as well as. As soon as it becomes a char array type, it actually means now 5 is no more stored as an integer 5. It will be stored as a character 5 at index 0 onwards. And that will mean all values. And because it's a character array, and if we read it as a string, maybe I will say null character at the last will be available. So I will be treating it as a string and reading it using percentage %s or some string symbol. And then accordingly, I can have null character at the end. So I have this as a postfix expression. But now, having said that, it means you are having character 5 stored, but you have to handle it as integer. So the question you have to understand is how characters are stored, how character 5 will be stored into the computer inside. So how A is stored inside? It is stored using ASCII code. You know what is character alphabets A is ASCII code. For example, you might know it is 65 probably. Similarly for small a, etc. Similarly, character 0 to character 9, they are not only digits, they are also alphabets or characters also. They also have their own ASCII code. And let's say if I say a 0 has ASCII code, let's say 100 or let's say 50. Say its ASCII code is say 50. I'm not intentionally telling you, you should try to find out ASCII code from somewhere, or even without knowing ASCII code also, it is possible to do programming. But if 0 has ASCII code 50, then 9 will obviously have 59. So 50 will be 0. Then you will have 51 for character 1. Then you will have 52. They are always in sequence in the computer. So 59 will be the ASCII code for 9. But it might not be the correct code. Find the correct code, I will say. So that is your problem, to find out the correct ASCII code of 0 and accordingly others. For 0 up to 9. Why? That will be needed while you are doing the programming. So now once I have understood this, I can start my programming. So I'll say, I will need one postfix expression to be evaluated. And this is a function. This requires the parameter of a postfix expression as a string being passed. And I have to find its return type. What should be that return type? Obviously now, this will be returning value calculated like -18. Or 20 or 5. So it could be simply going to be, let's say, int for the time being. Is it the best? I'm leaving it to you. That is int okay, or should I think of doing something beyond? But yes, maybe you can think int could be a good choice. So once I have taken int, I will start working further. And now I will say, let's start writing the further code. From where I have to start? From the first position of ASCII code, from the first position of the postfix expression, and proceed in the sequential manner. So obviously, one way could be I can say I equal to 0, and then I can have a loop. Now, it could be a loop how many times? We have to go up to the last character, and that last character, going up to the last character will actually mean that I'm going to use this up to the final position of this postfix. That could mean I'm going to use it as either a kind of a for loop, because I know how much is the length of this, and length you can calculate using strlen, or you can also use a while condition. It's your choice, whichever you want to use. But of course, if you use while, maybe you will say while postfix I not equal to null character. So if you have not reached to null character, you will be keeping on repeating, or otherwise you could use a for loop for I equal to 0, I less than length, I plus plus, and of course I gets automatically incremented. So either of this you can use. Once you start using this, now we have to do the rest of the programming. First thing, based on postfix I will take a decision. So first case, first time I get some alphabet or digit 5. 5, it's an operand. For operand, logic is simple. I have to push. So first of all, I must be able to check if postfix I is operand or not. How to check that? Your ASCII code range will help you to know that. Or you could compare it with character 0 and up to character 9. If it is in that range, obviously it is an operand. If operand, what to do? Push. So push could be a simple choice. In this case, how to push? You have already done. Use a global array stack. So global stack, use top, and you can use that and you can do that push operation. Stack of what data type? I will need in stack sometimes 12 to be stored, sometimes 30 to be stored, sometimes minus 18 to be stored, and etc. etc. So I must have stack of maybe int data type. Is int the best? Again, I will leave it to you. But at least I need int. So you could take your int stack, but now the challenge comes. You are pushing character 5, and this character 5 should not be directly pushed as it is. It should be actually stored as integer 5. If you push character 0, it should be actually stored as a value 0 in the stack. So that will require correspondingly the push, etc. to be adjusted, and maybe you have to operate with some data and then you can do that. So instead of directly saying push postfix I, you have to do some mathematical calculation. I leave it to you how to do that. And once this is done, other case. So if it is not operand, else guaranteedly mean it's an operator. Now, in case of operator, what I have to do? For example, I reached to plus. Plus I reached guaranteedly mean I need to take out operand once and 2 operands. So effectively, it means I have to pop out 2 operands and ensure the ordering of these operands from stack. They are integer now, obviously. And let's say they are saved into 2 variables named as operand 1 and operand 2. Then what to do? Now, based on whether it is a plus or minus or a star or a slash or power. Accordingly, some calculations need to be done. For example, I got 5 and 7 and I want to do plus, so I should get 5 plus 7, 12. How to do that? Can be simple. I can use, of course, a switch case. So switch over postfix side, and then I can have multiple cases. First case, let's say I'm talking of a plus. Plus means what? Plus means operand 1 and operand 2 are to be added together. So I can take a result variable and can say operand 1 plus operand 2. If done, what next? Once I have found 5 plus 7 as a 12, now this 12 will be pushed into the stack. So now I can easily say push result. And because the result is integer guaranteedly, I have done this plus, so this will be pushed. Similarly, I can have case for the minus, etc., etc. For power symbol, you can accordingly you either write your own function or you can use power function of the math.h as per you. So you can write your own function or power function. So once you follow this programming, you are effectively having for all different operators. Later you can add more operators and do that. And once all that is done, obviously, if you are using a while loop, you will have I++ to be done. And if you are using for loop, no I++ needed, keep on repeating the process. Once it is completed, once you are having the whole postfix expression completed, then you are out of the loop. So now loop over. Loop over means all operators and operands have been applied. My result is ready into the stack. So I can write now result equal to again pop that will be finally calculated and I must return the result. So based on this, my result will get finally computed and it will be returned back to the corresponding main or calling function. So by this, effectively, my more or less the work is over. So I give you one homework that you have to implement a function for postfix expression evaluation with the assumptions which I have given. For evaluating a postfix expression with assumptions which I have already given. The assumptions we have mentioned. But having said that, I go further and discuss a bit more about the conversion process. We said we got postfix expression, but how did we get postfix expression? We said this is also a conversion using stack. How stack comes into picture? What will be the stack's role? Why do I need a stack, etc., etc. So let's understand this working so that you can think over how this programming should be done further. Let's take some expression, say the same expression I take 5, 7 plus 6 star 3 plus 2. Let's say this was the expression, infix expression. So, sorry, let me write it in infix form. It was written as 5 plus 7 minus 6 into 2 plus 3. So this was an infix expression. How this will be converted to postfix? One thing is clear, the operands ordering will be always remaining in the same way, and operands don't make any difference. They will always come in this order because one is left operands, other is right, so they will always follow this order. But operators will make a difference. So operators decide which one will be operated on what data and in which particular way. For example, when a star comes, it says others have to wait. When a bracket comes, it says everybody has to wait. So your board mass or your priority helps me in deciding the corresponding precedence or priority of this. So priority of operators helps me in deciding which way it will be doing. So let's try to make a logic for that and understand the stacks working. So if I have expression like this, how it will be working is simple. As soon as I get some operand, I will say, yes, I will make a corresponding postfix expression array. And in that, all data will be generated one by one. 5, straight away 5 can come. Not a problem at all. Then comes plus. Now, plus is an operator. Operator will definitely require both operands before getting into the postfix expression. So anytime an operator comes, current operator is guaranteedly supposed to go into stack. So I'll say plus will go guaranteedly into stack because stack is initially empty, so no decision, no issues at all. Then comes a 7, done. Now comes a minus. Now this minus guaranteedly will go into stack, but before that, will this plus be allowed to be operated? That depends on board mass rule. So in board mass rule, I said add and subtract. Remember, add and subtract don't have a different priority. Add and subtract have same priority. Although A is written before that, but it doesn't mean that add has a more priority. Add and subtract have same priority. Similarly, divide and multiply have same priority. So if they have same priority, that means the fun which came first will get processed in this case. In this case, normally we say there is another word which is called as a precedence. And a precedence means for the same priority, the ordering. For the same priority, ordering means effectively ordering could be left to right, or it could be also right to left. But most of the time it is left to right. So for the time being, I don't bother and I say always it will be left to right, means the first which came that will be processed. For plus, for minus, for star, we know all this ordering automatically being followed. But yes, you should know there is some word which is known as a precedence, and for some cases it could be a different precedence. But for the time being, I say minus and plus have same priority. So that will mean plus came first. So plus will be allowed to be operated, automatically meaning that if inside the stack, the priority of minus and this priority was equal, this priority was not higher. If not higher means previous operator is allowed. So plus will come. That directly gives me a hint in my coding. So if priority was not higher, plus came, plus was removed, and obviously minus is guaranteedly pushed. Then comes a 6, 6 stored here, obviously. Now came star. Star has a more priority than inside stack's symbol. So on the top of the stack, there is a minus, but because a star comes, this means this minus has to wait. So this priority is higher. Higher priority will mean this minus will not come out and it will still wait and I will push star. Current operator has to be pushed guaranteed. So star will also get pushed and minus will remain below star because the star will be completed first. When for star also the operand must come. So it has to still wait for some time. Comes bracket. Small bracket guaranteedly means at present it cannot be completed till I reach to closing bracket. So for small bracket, always push. I will say whenever I'm getting a bracket, I will be guaranteedly pushing bracket. After that comes a 2. So I will have a 2 stored here. After that comes a plus. Plus will be compared with the corresponding priority within the bracket, within the stack, because plus could have before that minus, etc. But because bracket is there, so I will say fine, bracket should have a lower priority, plus has a more priority than this in terms of stack processing, because plus has to get corresponding data and bracket will ensure that I will be again pushing. So plus will be pushed. Then comes a 3 over bracket. Now, bracket guaranteedly means the closing bracket means up to opening bracket work is over. So I will have here, so this plus went here, plus was inside the stack. I had 3 here. And now as soon as I get closing bracket will mean pop until you reach back to starting bracket, because up to starting bracket work is over. So plus will come here, and after that bracket will also be popped out, but plus bracket will not be stored here, work over. After this nothing left, so this will be popped out one by one till the last position. So this is how my postfix expression got created from the corresponding infix expression. So now you can see this is how I got this. I have roughly explained how it will be done through stack, and next class we will be discussing of programming for this. So I will give you a homework now, or I will say practice problem. Those who want to try, I will give you some extra practice problem. I'm expecting you, some of you, to do that. So practice problem for some of you, or those who must try, those who are good programmers, they must try. Number 1, take a complex infix expression and compute its equivalent postfix expression by defining your array of a stack by using your stack and methodology which we just discussed, and show stack contents after every operation. Show the stack contents after every push or pop. Means I'm expecting you to have some complex infix expression, let's say a plus b star c slash d minus e star f slash g plus h bracket closed, and then some more bracket minus x power y, something like this. Try to calculate the corresponding process so that your process becomes clear to you, not programming expected. Then I say, try to write program, or at least the main logic. I try to write the function for this conversion, or at least main logic for converting an infix expression, for conversion of an infix expression to postfix expression. So with this, I will now say stop, and I have given one homework which you must do. That is an evaluation of a postfix expression, and I have given you optional or practice problem. I have given you 2 problems for this, which is related to infix to postfix conversion. So try these, and next class we will be going for programming related to infix to postfix conversion and understand micro details of that. Bye-bye. All the best to all of you. Let me stop now.